Greetings, A-level chemists. Today's question is all about weak acids. So we have a table which has 3 different weak acids and the associated acid dissociation constants given in the table also. And our first job is to determine the pH of a given concentration of a solution of this acid, which is propanoic acid. Okay, so I'm just going to highlight propanoic acid. Here it is, and here is the associated Ka. So we have to determine the pH of this solution. Okay, the first thing I'm going to do is actually write out the dissociation for this acid. So C2H5, COOH. Now remember, it's a weak acid, so it partially ionizes or dissociates in water. And this is my acidic proton. So I get C2H5, COO minus, and H plus. Aqueous, aqueous, aqueous. Okay, where can I go from here? Well, let's write out an expression for Ka, the acid dissociation constant. Now, this is going to be the concentration of the products. So the concentration of the propanoate ion multiplied by the concentration of the H plus ions all over the concentration of the acid. Okay, so all over the concentration of propanoic acid that we start with. Okay, let's think about what terms we know and what terms we don't know. Well, do we know the Ka? Yeah, we know the Ka. It's given to us in the table. The other term that we know is the concentration of the weak acid. So we know the denominator term. Okay, what we don't know is H plus. And you might be thinking, well, we actually also don't know the concentration of propanoate ions at equilibrium. However, what assumptions can we make for weak acids? Well, let's do this up here. So assumption number 1, at equilibrium, we can say that the concentration of C2H5COOH initial is roughly equal to the concentration of C2H5COOH at equilibrium. So whatever concentration we start with is a concentration at equilibrium. Why can we make that assumption? Because the extent of ionization is low. So we just assume whatever concentration of the acid we start with is the concentration of the acid that we end with. Okay, what is our other assumption at equilibrium? So at equilibrium, we can assume that the concentration of the propanoate ions and the H plus ions is equal. So when this thing dissociates, we're ignoring any dissociation or autoionization of water. So we're just going to say that the concentration of the propanoate ions, or more generally the A minus ions, equal the concentration of H plus ions at equilibrium. So if we lose X amount of the reactant, we're going to get X amount of the propanoate ions and X number of moles of the H plus ions. So if that's X and that's X, these guys are equal to each other. Good assumptions, because that helps us out here. So what we can do is let's rewrite Ka if these guys are equal. So we can rewrite Ka as H plus squared all over the concentration of the propanoate ions. Okay, now what we can do is rearrange for my unknown, which is H plus. So if I'm rearranging for my unknown, which is H plus, I'm going to multiply both sides by the denominator term. So this becomes Ka times the concentration of the propanoic acid, which is equal to H plus squared. And then I want to get rid of that pesky square term on the right hand side, so I'm going to take square roots of both sides. So if I square root both sides, what am I left with? I am left with square root of Ka multiplied by C2H5 COOH concentration of, and that is equal to H plus. Okay, do all the rearranging without the numerical values first, then substitute the values in, and we'll do that in number 5. So we know what Ka is. It's 1.34 times 10 to the minus 5 multiplied by the concentration of acid that we started with. It's 0.0810. And then what we're going to do is take the square root of all of this, and that's equal to my H plus concentration. So let's show you how we might do it. Okay, so let's see how we might do it on a calculator. So what we're going to do, brackets always helpful here. So 1.34 times 10 to the minus 5 multiplied by 0.0810, close brackets, and that equaled whatever it equals. And then I'm going to square root my answer, and that is my H plus concentration. So my hydrogen ion concentration equals 1.0418 times 10 to the minus 3 moles per decimeter cubed. And now I've got my hydrogen ion concentration. What can I do? I can then plug this into the equation for pH, which is the negative log base 10 of the hydrogen ion concentration, and then let's substitute that value in. So 1.0418 times 10 to the minus 3, and that gives us a pH of, let's go through this, so minus log of my answer equals 2.98, and there you go. Always 2 decimal places. In fact, it even tells you that in the question. Now, it seems like a lot of work, but once you know the approach and you know all the equations, this is a relatively trivial question. Okay, ta-ta.